Welcome to Jeremy's IT Lab. This is a complete course for the CCNP ENCOR, Enterprise Core exam. In this lab, we'll practice the basic multiple spanning tree protocol configurations we covered in the previous lecture video. These are the absolute basics: creating MSTP instances and assigning VLANs to them. In the next video, we'll cover more advanced topics, including MSTP regions and connecting different regions together. Let's get started with step 1. It says to create VLANs 1 to 100 on switch 1, switch 2, and switch 3. We should configure the links between switches as static trunks that allow only VLANs 1 to 100, explicitly disable DTP, configure VLAN 999 as the native VLAN, and finally, confirm how many BPDUs are sent every second. I'll start with switch 1 first. From the CLI of switch 1, conf-t, and then VLAN 1 to 100 to create VLANs 1 to 100. Now, something you might not be aware of is that these VLANs aren't actually created yet. Let's check. Do show VLAN brief. Only the default VLANs, 1 and 1002 to 1005, exist. Then, if I use interface range G00 to 1 to configure switch 1's links, and then use do show VLAN brief again, now the VLANs have been created. When you enter VLAN configuration mode for a particular VLAN or set of VLANs, the configurations aren't applied until you leave that configuration mode. I'm sure some of you are aware of that behavior already, but I'm just pointing it out since the same thing applies to the MSTP configurations we'll do later. Now let's configure these interfaces. First, I'll use switch port trunk encapsulation.1q. This command isn't supported on modern Cisco switches, but on these iOS V switches, it's necessary. Then configure trunk mode with switch port mode trunk, and disable DTP with switch port no negotiate. Let's allow only the necessary VLANs. Switch port trunk allowed VLAN 1 to 100. And then configure an unused VLAN as the native VLAN. Switch port trunk native VLAN 999. And then I'll exit. Switch 1's done. Now switch 2. Conf-t, create the VLANs with VLAN 1 to 100, then configure the interfaces, interface range G00 to 1, set the encapsulation, switch port trunk encapsulation.1q, then trunk mode, switch port mode trunk, disable DTP, switch port no negotiate, next allow VLANs 1 to 100, switch port trunk allowed VLAN 1 to 100, and then the native VLAN. Switch port trunk native VLAN 999. Exit. Finally, switch 3. Conf-t. First, create VLANs 1 to 100. Then the interfaces. Interface range G00 to 1. Set the encapsulation. Switch port trunk encapsulation.1q. Enable trunk mode. Switch port mode trunk. Disable DTP. Switch port no negotiate, then allow VLANs 1 to 100. Switch port trunk allowed VLAN 1 to 100. And then the native VLAN. Switch port trunk native VLAN 999. Exit. The final part of step 1 asked how many BPDUs are sent each second. Let's check the current version of STP that is running on these switches. Do show spanning tree. It says Spanning Tree Enabled Protocol, IEEE. This means that PVST Plus is running. So there should be a unique STP instance for each VLAN, each sending its own BPDUs. To confirm, I'll right-click on the link between switch 1 and switch 2 to do a packet capture. Let's click on Settings and set the max packets to 500 and click Apply. And let's start the packet capture. The text is a bit small, but take note of the number of packets captured down here. We just set the maximum number of packets in the capture to 500, but in the span of about 10 seconds, it fills up and stops the capture. That's because there are 100 STP instances running, each sending a BPDU once every 2 seconds. So that's 100 BPDUs every 2 seconds. This isn't a good use of network resources, so let's configure MSTP to fix it. Let's go back to the lab guide for step 2. It says to enable MSTP on the switches. We should check the MSTP cost of each port before and after. Then, explicitly configure STP short costs and see if it affects the port costs. Finally, we should once again check how many BPDUs are sent every second. Okay, let's return to switch 1 to enable MSTP. Before that, use do show spanning tree and check the cost of each port. These gigabit Ethernet ports cost 4. Okay, now enable MSTP with spanning tree mode MST. So MSTP is enabled. Let's check the port costs now. Do show spanning tree. The cost increased from 4, the standard short cost for gigabit Ethernet, to 20,000, the standard long cost. MSTP always uses the long costs. In fact, if I use spanning tree path cost method short to enable these short costs, it won't change. Do show spanning tree. These gigabit Ethernet ports still cost 20,000. Now let's enable MSTP on switch 2 and switch 3. On switch 2, use spanning tree mode MST. And then on switch 3. Spanning tree mode MST. Now let's check how many BPDUs are being sent. Return to that packet capture on the switch 1 switch 2 link, and then click start again. This time, only one BPDU is being sent per second. There is a single MST instance, MSTI0, and all VLANs are assigned to it by default. MSTI0 is called the IST, internal spanning tree, and it plays a special role in MSTP that we'll cover in the next video. For now, let's move on to step 3, in which we'll configure each switch's priority for the IST. It says to make switch 1's priority 1 increment higher than the lowest possible priority, make switch 2's 2 increments higher than the lowest possible priority, and leave switch 3's priority as the default. The lowest possible STP priority is 0, and it can be configured in increments of 4096. So we'll make switch 1's priority 4096 and switch 2's 8192. I'll configure switch 1 first. The command is spanning tree MST0 priority 4096. And let's confirm with do show spanning tree MST. First, look at the top line. MST0 VLANs mapped 1 to 4094. So, all VLANs are mapped to MST instance 0 by default. Under that, the bridge line shows this switch's information, its MAC address, and its priority of 4096. As I mentioned in the lecture video, in MSTP, the extended system ID is the MST instance ID. This is MSTI 0, so we add 0 to 4096. In PVST Plus and rapid-pvst Plus, the extended system ID is the VLAN ID, so just keep in mind that it's different in MSTP. The next line says root, this switch for the CIST. The CIST is the common and internal spanning tree. This is a more advanced MSTP topic that we'll cover in the next video. This just means that switch 1 is the root bridge for the CIST. Then there's timer information and a summary of the switch's interfaces. Okay, let's configure switch 2's priority next. Spanning tree MST0, priority 8192. And let's confirm here too. Do show spanning tree MST. The output is slightly different on switch 2 because it isn't the root bridge. Notice it shows information about the root bridge, switch 1. Port G00 shows this switch's root port. So G00 is switch 2's root port, as expected, since it's directly connected to switch 1. And then the following section shows the regional root, which is also switch 1. We'll see the difference between the root and regional root in the next video, when we cover MSTP regions. Okay, let's move on to step 4. It says to configure MSTI1 for VLANs 1 to 50, and MSTI2 for VLANs 51 to 100. We should make switch 1 the root bridge for MSTI1 and the secondary root for MSTI2, and the opposite for switch 2. It should be the root for MSTI2 and the secondary route for MSTI1. Before configuring the VLAN mappings, I'll configure the priorities, switch 1 first. The instructions didn't specify the exact priority to configure, so I'll use spanning tree MST1, route primary, to make switch 1 the route bridge for MSTI1, and spanning tree MST2, route secondary, to make it the secondary route for MSTI2. I generally recommend using the priority command instead of the route command, but just keep in mind that you can use these commands in MSTP too. Okay, let's configure the opposite on switch 2. Spanning tree MST2, route primary, and spanning tree MST1, route secondary. Okay, we've configured the primary and secondary routes for the two instances. Now let's configure the VLAN mappings. These configurations should be identical on all three switches, so I'll start here on switch 2. First, enter MSTP configuration mode with spanning tree MST configuration. From here, we can map VLANs to MST instances. First, map VLANs 1 to 50 to MSTI1. The command is instance 1, VLAN 1 to 50. And then map VLANs 51 to 100 to MSTI2. Instance 2, VLAN 51 to 100. Now let's check the mappings with do show spanning tree MST configuration. The output of this command only shows instance 0 with VLANs 1 to 4094. As I said at the beginning of this video, like VLAN configurations, configurations made in MSTP config mode only take effect after you exit the mode. From MSTP config mode, you can use the command show pending to view the settings that are waiting to be applied. This shows the configurations we just made. VLANs 1 to 50 in instance 1, 51 to 100 in instance 2, and the rest in instance 0. You can also use show current to view the current configurations before you apply any changes. The output is the same as do show spanning tree MSTP configuration that I did above. And one note. Notice that show pending and show current don't require do in front of them. That's because show is a valid command in MSTP config mode. I'll use the question mark, and notice that show is a command here. Type show, and then use the question mark again. As you can see, the only two options are current and pending. This CR means you can also just hit enter to execute the command as is. This shows the same output as show pending. Anyway, that's enough of an aside about the show command. I'll use exit to apply the configurations. And now, let's configure the other switches. Switch 3 next. Spanning tree MST configuration. Map VLANs 1 to 50 with the command instance 1, VLAN 1 to 50, and then map VLANs 51 to 100 with instance 2, VLAN 51 to 100. And don't forget exit to apply the changes. Finally, I'll configure switch 1. Spanning tree MST configuration, instance 1, VLAN 1 to 50, instance 2, VLAN 51 to 100, and then exit. Okay, that's all for step 4. Finally, let's move on to step 5. It says to confirm the status of the LAN after these configurations. We should verify that the instances were properly configured with the proper VLAN to instance mappings. Then verify the route bridge of each instance, and once again, check how many BPDUs are sent every second by doing a packet capture on each link. I'll confirm on switch 1. First, use do show spanning tree MST configuration to check the VLAN to instance mappings. As we configured, VLANs 1 to 50 are mapped to instance 1, and VLANs 51 to 100 are mapped to instance 2. The rest of the VLANs are mapped to instance 0, the IST. Now let's check the route bridge of each instance. We can do that for MSTI1 with do show spanning tree MST1. Specifying the instance ID limits the output to only the relevant instance, which helps when there is a lot of output. So this switch, switch 1, is the route for MSTI1. How about instance 2? Do show spanning tree MST2. Okay, switch 1 isn't the root for this instance. It says switch 1's root port is G00, connected to switch 2. So switch 2 should be the root bridge as we configured. Let's go on switch 2 and double check. Do show spanning tree, MST2. Okay, the root is this switch for instance 2. Finally, let's check how many BPDUs are sent every second. There are 3 MSTP instances. So what do you think? First, I'll right-click on the switch 1, switch 3 link and do a packet capture. Click Start, and let's see how many BPDUs are sent. It looks like only 1 BPDU is sent every 2 seconds. That's because in MSTP, only the IST, instance 0, sends BPDUs. The BPDUs sent in instance 0 include the necessary information for other instances too. Let's look at the details of these BPDUs. The font size of these packet captures in CML is a bit small, so I'll open the capture in Wireshark. I've included this packet capture in the lab files, so you can open it yourself too, if you aren't able to do the lab yourself and get your own packet capture. These BPDUs are all the same, so click on any of them. Then, expand the Spanning Tree Protocol section to see the contents of the BPDU itself. The protocol version identifier is 3, meaning MSTP. The BPDU type is rapid/multiple spanning tree. Basically, it's an RSTP BPDU with an MST extension. Let's open up that MST extension section at the bottom. I won't go through all of this info yet, but notice that there are sections for each MST instance at the bottom, MSTI1 and 2. Instance 1's root is switch 1, with a MAC address ending in 3A82 in my lab. And instance 2's root is switch 2, with a MAC address ending in 2C8B in my lab. I'll just point out one thing. Even after expanding the section for each instance, notice that there is no information about the VLAN mappings. MSTI1 section doesn't say that VLANs 1 to 50 are mapped, and MSTI2 section doesn't say that VLANs 51 to 100 are mapped. So how do these switches know they have the same mappings? That's the role of the MST-config digest, shown here. We'll cover this in detail in the next video, but basically, this is a hash that is calculated from the VLAN to MST instance mappings configured on the switch. Switches compare this value, and if it's the same, it means that they have the same VLAN to instance mappings. They don't need to compare the actual mappings. They just need to compare this hash. Switches in the same MSTP region must have the same mappings, so their MST config digests must match, but we'll cover that in the next video. Okay, let's quickly return to the lab. Next, I'll do a packet capture on the switch 2, switch 3 link. After starting the packet capture, leave it running for a few seconds. Okay, just like the previous link, there is only 1 BPDU sent every 2 seconds. Now let's do a capture on the switch 1, switch 2 link. Leave the capture running for a few seconds, and you should notice something different. Instead of 1 BPDU, 2 BPDUs are sent every 2 seconds. Why is that? Notice that there are 2 source MAC addresses. One is switch 1's, and the other switch 2's. So both are sending BPDUs. Earlier, I said that only the IST sends BPDUs, and that's true. Notice that in the info column, all of these BPDUs indicate priority 4096, switch 1's priority in the IST, and extended system ID 0, so MST instance 0. So why does switch 2, which isn't the root bridge for the IST, send BPDUs to switch 1, which is the root bridge? Switch 2 G00 is a root port in MST instance 0, and normally, root ports don't send BPDUs, only designated ports. This isn't something that ENCOR will test you on, but basically, it's because switch 2 is the root bridge for MST instance 2. This means that switch 2 G00, although it's a root port in the IST, is a designated port in MST instance 0, and needs to send BPDUs. We won't delve into the details, but I just wanted to point this out in case you're confused about why BPDUs are being sent in both directions over this link. So in this lab, we configured and analyzed the basic MSTP concepts that we covered in the previous lecture video. With these basic configurations, we were able to achieve load sharing among these links. Switch 1 is the root bridge for half of the VLANs, so traffic in those VLANs will be forwarded toward switch 1. And switch 2 is the root bridge for the other half of the VLANs, and traffic in those VLANs will be forwarded toward switch 2. In the next video, we'll dig deeper and examine some more advanced MSTP concepts. That's all for this lab. I hope it was helpful. Thanks for watching. Before finishing this video, let me thank my JCNP level channel members who support me through YouTube channel membership. To become a member, please click the Join button under the video. Thanks to Jonathan Makara, Velva Jacob, George, Nasir Chowdhury, Gustavo Macedo, Marcel Lord, Dragos Hernea, Mayor Salman, Vitaus194, Mark Jackson, Bold1C1U, Gerald Guillaume, Fristas1207, Hector Hernandez, Arpad Conives, 5 Feet, Owad, Daniel Brown, Jose Alvarez, Hussein Yavuz, Samuel Tavares, Kevin Hayes, Roger Bratseth, Brian Grant, Georgi Gemejev, Cats for Life, Adelson Pereira, Farad69, Madmark 50484, Alexandru Stratan, Hiago Bicalho, Lucian Stoichitoyu, DMJ2, Kurt Nell, Dear Diso, Steve Cox, Jasper Yim, Pedro Hartman, Tricky Mickey 123456, Ivano Capuano, Jefferson Steelflex, Toxic, Wilmer Romero, Sinan Sarisinar, Gio, Daniel Andrade, Mike Crumby, Dragos George, Jairo Francisco, Filip Jovanovic, Mateusz Zashinsky, Ruben Hernandez, Electro Jedi, Trevor Goldman, Gavin Paul Tech, Sunny Idigu, Jeffrey C., Chitsinde, Stephen White, Edificare, Fio Hein, Dimitro Lis, Fares Al-Zaharani, Jean-Marcel Belmont, Mikhail Chapsky, Hemanth Jabalpuri, Darius D., Juan Morales, Gonzalo Nicolas, Doomed Soul, Christine Schubert, Julio Maya, Josi, Prashanth M., Egreso, Komlan Kapedemi, Gökhan Doymaz, Anand Abyankar, JFlow99, Clyde Makorombindo, Adekola Ismail Salami, Orlando Flores, Ray Enriquez, Adrian Martinez, MD Daniel Witz, Gabriel Afolabi, and GG7. Sorry if I pronounced your name incorrectly, but thank you so much for your support. Thanks to you and my other supporters, I am able to make these videos and release them for free on YouTube, so I really appreciate the support. Another great way to support the channel is to like the video, leave a comment, subscribe, and most importantly, share this video with others. So if this video was helpful, I'd appreciate it if you did any of those. Thanks for watching.